Okay, so today we're gonna talk about AWS DynamoDB. It's one of AWS database services, as you can see here, and it's part 14. So we're at part 14, which is like really great. At the end of the lecture, we're gonna do a very small lab. We're gonna create a table, add items. We're gonna talk about it more. So let's get into it. Content of the slides. We're gonna give a brief introduction, key features, how it works, use cases, benefits, and pricing. Okay, so introduction. So I don't want to read off the slides, so let's go to our handy dandy Canva whiteboard. And yesterday, a quick recap on yesterday, we've talked about SQL. I'm getting better, guys. I'm getting better. So I know I jinxed. حسيت I know SQL. Okay, so oh wow, I know SQL. Okay, the main difference between SQL and NoSQL, which said this is structured and this is not structured, so structured query language, and this is no structured query language. So basically obvious. So SQL is basically, we said it's rows and columns. Anything else, it's NoSQL. So today we're gonna talk about NoSQL. Yesterday and before we talked about SQL and relational database services. So today we're gonna talk about non-relational database service. Okay, so as we can see here, it's a fully managed NoSQL database that is offered by AWS. It also provides a lot of services, of course, because SQL or NoSQL database, especially DynamoDB. So DynamoDB is serverless, and we've talked about serverless. So DynamoDB is serverless. And we've talked about what the meaning of serverless. It means you only care about the thing you want. You don't care about anything else. Before we go into a deep dive, I think I have this slide I want to share. It's called a serverless mindset. I hope I can find it. Okay, just give me a moment, guys. I'm gonna find the serverless mindset slide. I'm gonna talk about it before going into DynamoDB because I think I'll just leave it to the serverless. I'll leave it to the serverless mindset lecture that will be up. Okay, so as we said, DynamoDB is serverless, and there's a special mindset you have to get into so you can start using serverless services. One of which is DynamoDB. Of course, it has a lot of things, and we're gonna talk about them right now. So the first feature of DynamoDB that it is very scalable. So it has two features. It has auto-scaling features and it has what is called a DAX or DynamoDB Accelerator. So I also want to talk about this thing that we have both in RDS and in DynamoDB, which is called open connection points. So every time a user tries to connect to a database, so let me have my user. Here's my user. And let's say a database. I hope there's something for free. Thank you, Canva. You gave us, yeah, this is great. Okay, so every time a user tries and have a connection with a database, it's gonna create what's called an open connection. So open connection. So this open connections slows down the process and slow down everything that is related to databases, if it's for RDS or if it's for DynamoDB. So having these open connections is bad. So let's say open connections equal bad. So let's say if we're having this weather application that we've talked about, so Arabia Weather, which is in my country that is mostly used. So I'm actually looking for Amman, Jordan, and for today. Thank you. I don't want any kind of advertisement. So I want to look for today, which is 8 of August. So can you imagine how many customers need to look at 8th of August? So if we have this thing, like if we have like a caching layer, so cache, so a cache layer, which stores 8/8/2004 let's say temperature, so temperature. Yeah, it's wrong, I know. Okay. 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 So let's have a cache layer in front that stores the temperature for that specific day. I think it's still wrong, which is fine. So there's E here. So instead of having these open connections, we can the user can connect to this cache layer to retrieve the information, which will minimize the open connections. So minimizing open connections. And if there's anything that's beside it's gonna take it from the database itself, and then it's gonna return it, and it's gonna return it to the user. So this caching layer minimizes open connections. Either it's in DynamoDB or it's in RDS. Of course, we said as much as we have open connection, it's a bad thing. It's gonna affect the performance of the database in general. So this caching layer in RDS, so caching layer in RDS is called RDS proxy. And in DynamoDB, oh, wow. So in DynamoDB, it's called DAX. So these proxies or DAX, these what are called an in-memory, let's look here. So it's called in-memory layer, or it provides caching services. So cache basically is just, it takes data from a database and it saves it in its current state. Like as we said here, it stores the temperature for that specific date, which is great if a user is gonna like keep using and keep opening to check out today's weather. But let's say if we have like we want to see other dates, this caching layer would take this kind of data from the database, and it has like a certain period of time, and it's gonna like take another copy, so the data can be consistent and relevant, let's say. Does anyone have any kind of question on caching and this kind of stuff? It's a bit like advanced, but the concept itself you need to understand. فخليني أعيدها في العربي. الكاشنج لاير أو بيحكوها الكاش هي زي إشي بس بحفظ باخذ copy من الداتابيس. It takes a copy from a database for a specific like, period and it keeps it for itself and it's much faster وهي كثير أسرع أنها تعطي رد للمستهلك. فهي كثير أسرع. It's faster than just having to connect to a database and then returning the response. Okay. It also helps with the performance of the database. And this is how DAX looks like. So as you can see here a lightning bolt. And it's a caching layer. So this is DAX. Also, if we open the AWS console and then we open DynamoDB, and we went down here, you can see that this is DAX. Let's go to clusters. Yeah. And if we open DAX, we're gonna see it's DynamoDB accelerator. Oh, well, no, DAX AWS. It gave me, okay, that was weird. So this is AWS DynamoDB accelerator, and here you can see the documentation of it. As you can see here, as I said, these are what called proxies or caches. So your application is gonna hit the cache, and if it doesn't have this kind of information, it will go back to the DynamoDB and get this kind of information. And this is also similar to RDS proxy. Sorry, RDS proxy AWS. It's also similar to it. So if we went, is there any kind of doc? AWS doc. Okay. So here you can see that it is the same. I don't know why there is no planning where. I'm trying to find where to find. I'm trying to find the same drawing, but I can't. But it works the same, guys. I promise. Okay. So we talked about scalability. It also has auto-scaling features. Of course, it's serviceless. You don't even manage the scaling. It just scales up and down based on demands. It supports data models, like in a typical database, but more advanced. So it has a table, item, and attributes. So it organizes data into tables and contain items in rows and attributes in columns. Okay, so guys, it's like you're gonna ask me, it's relational database. We're talking about rows and columns. It's literally right here. We talked about rows and columns. Yes, that's true. But SQL is written by SQL language or structured query language. But NoSQL databases, especially DynamoDB, is written by JSON. So I'm gonna show you an example right now. So this is how it's written. So this is the columns that we're talking about, and this is the rows. Oh, sorry, no, I need this. Okay. So this is the column or the attributes الصفات اللي احنا بدنا نحكيها. والصفات هي student ID or identifier. So the attributes or the thing you want to call this thing, so it's a student ID, and the value of this attribute is N1. Also, another attribute is name, age, and major, and the value of these attributes is computer science 22 and John Doe. So it's really different than writing in SQL language. SQL language is more structured, it's more understandable. Also, this is understandable, but it can be more complicated than this. And we have what's called a primary key. It's not called a primary key, it's called a partition key, yeah. So we have two keys, which is partition and sort key. So if you want to go to tables, and if you want to create a table and call it student records, or I'll leave the hands-on till the end. To be honest, I don't want to like get ahead of myself, but that's fine. So we have what's called a primary key, which is combined of two things. So it's combined of what's called a partition key. Let me add a heading. So a partition key and a sort key. And of course, a sort key is optional. The not optional one is the partition key. So this is going to create what's called a primary key, and this is what's in database, what's used for identification. So primary key. So let me fix that. Go back. That's even worse. Okay. So this is not optional. This is mandatory. And this is optional. And a primary key is what is used in what's called identification key and can be used for identifying and other tables. So you can connect it to other tables using this kind of primary key. So this is what's in database 101, let's say. Okay, so we've talked about scalability, we have auto-scaling, we have DAX, we've talked about table items attributes, and we have talked about primary key, which is consists of two things, which is a partition and a sort key. The third thing is we have flexible data type, so it can support different type of values, include string numbers and binaries. We're gonna see these things. Of course, if you're into programming, you're gonna see we have multiple data type. We have not just numbers, we have integers, floats, double, long, short, binary, string, character. Yeah, we have a lot. So even if we went to a database, so if we like wrote database value types, you're gonna see we have a lot. So we have date, we have a lot of strings, yeah. Here, yeah. car, varchar, binary, var binary, tiny blob, tiny text, text blob, a lot of stuff. Even numeric, bit, tiny int, bool, boolean, small int, medium int, integer, big int, float, float. That's a lot. If we have like value types for dates, and yeah, like as you can see here, we have a lot of value types. Of course, if you want to do a quick recap, we know that car is just a character like ABC. Why is nothing opening? Come on, nothing is opening. Why is it lagging? Wait, let me close and reopen it. Or try and refresh maybe. Okay, so as we said, car can be like characters. Basically, it's characters. So A, B, C, D. And string can be a bunch of characters like hello. Integers can be like numbers, which is 1, 2, 3. And float is a decimal point. So you have like 1.5, 2.3, this kind of stuff. So flexible data types. Also, we have what's called a consistent read and eventually consistent read. So strong is you get the most recent write, and eventually it's gonna give you the best read performance, but may not reflect immediate changes. So basically, what it means is, let's say we have changed an attribute or an item, and this item is not reflected it changes yet. So we're gonna get the old changes. It's not consistent. Eventually consistent read, it's not very consistent. Strong is consistent, so it's based on your business case. What's wrong? Okay. No, come on. Come on, what's happening with the internet connection? Okay. Also, we have the same thing. So multi-AZ replicas. We have replicas like Aurora and RDS, and we have the ability to backup and restore the point-in-time recoveries. We also have, we can across multiple AZs for fault tolerance. So we have the ability to do this in Aurora and in DynamoDB. Okay, so global tables. As you can see here, this is the globe. So you can make this database globally. And as you can see here, it enables multi-region fully replicated database, allowing application to read and write data locally in multiple AWS regions. So it's not just in one region, you can deploy it globally and let all the application around the world use this database for both read and write. This is something what's called streamed or DynamoDB streams. This is, it's literally streams. So it captures a time-ordered sequence of item level changes in table, and it allows for what's called analytics. So this is literally stream. So we have this item and this item. Let me make it a little bit bigger. And this item and this item, this is streams. So literally it's going this way. This is DynamoDB streams and brief. Integration, as you can see here, you can consider this one DynamoDB and this is other AWS services. So it can integrate with Lambda, S3, Kinesis. We're gonna talk about Kinesis and CloudWatch and S3, and it's gonna help with what's called an event-driven architectures and monitoring. So event trigger architectures, if you remember in our Lambda function, every time we upload something to an S3 bucket, so this is S3, this is gonna cause a Lambda trigger to send a message. So send a message, done. This is an event-driven architecture, and DynamoDB can help us with these kind of architectures. Security, we talked about encryption at rest and encryption in transit. We said encryption at rest is when it's in the database, it's not moving, and in transit when it's going between the user and the server. So it's gonna encrypt both data in both situations, and we can use IAM policies as well. Okay, so how it works. We can create a table, we can insert data, we can create and scan and update and delete. So we're gonna do this in a hands-on labs today at the end of this lecture. Okay. So use cases, why do we need DynamoDB instead of Aurora? A lot of reasons. We can use it for mobile and web applications. It's much more flexible than Aurora and RDS. It doesn't have any kind of structure, so you can add attributes and remove them as much as you want. It's also best used for gamings and IoT applications and serverless architectures, of course, because we said that DynamoDB is serverless and Lambda, and it's going to help us with our event-driven workloads. This is used for back-end and high throughput and low latency, such as user profiles and session management. Okay. And this is managed IoT streams, which is related to AWS streams, DynamoDB streams. Okay, we have a bunch of benefits for DynamoDB. The first one, of course, we've talked about. It's the same thing. So it's fully managed because it's serverless. It's also its performance at scale, so it's gonna scale up and down based on demand, again, because it's serverless. And it's flexible because you're paying for all of the things you're using. And it's high available and strong security. So I think there's this use case, AWS DynamoDB business story. So I think it has it like 2 million in 1 second, I guess. It like scaled up to 2 billions and millions of DynamoDB in like 2 seconds. I think I remember this kind of Kareem with over 50 million customers across 14 countries. Okay, that's great. Oh, guys, I'll send you the use case I was telling you about. It scaled like up to 2 million in like a few seconds. So we have on-demand and provisioned. Of course, provisioned is for predictable workloads, and on-demand is for unpredictable workloads. Main difference. Okay, guys, so do you have any kind of questions before we get into the labs and hands-on? Okay, that's great. So let me close these two. And let's get into our DynamoDB AWS console. And you can just like click your DynamoDB or go to services under databases, and you're gonna find here DynamoDB. So the first thing we're gonna have this page. Of course, we're gonna click anything that's orange. So the orange thing we have here is create table. So after we create a table, we can name it whatever we want. So it's gonna be about students. So we're gonna call it student records. Enter a partition key, which is gonna be student ID. Of course, it's gonna be a number because it's ID. And literally, your student ID is a number. Mine is the number. I don't know yours. And as you can see here, it's optional. Sort key is optional. I'm not gonna enter anything, and I'm gonna leave it on the default settings. Of course, you can customize these settings, but I don't need to do that right now. So now we have created a table, and we're gonna wait for like 3 seconds until it. I just refreshed it. We didn't even have to wait for 3 seconds. That's funny. Okay. So let's click on anything that is orange, which is explore table items. By the way, guys, this is how I learned AWS. I just clicked anything that is orange. So let's run the table. Of course, it has run, and you can see here we don't have anything, of course, because we haven't entered anything. So let's enter. Let's create an item. So let's click on create item. go to JSON view. I have a few examples that I have here. So I'll enter this first. So as we said, the attribute is student ID. The value of that attribute, which is a number for n, is 1. And then name in string, which is John Doe. Great. And age number is 22, and major is computer science string value. So create item. As you can see here now, we have seen that one item has been returned, which is the one we have entered right now. So let's do for the other ones. So let's get student 2, create item, the same thing, JSON view. Guys, you can create it, literally you can create one using this form, but you have to be very specific in like lowercase, uppercase. If you change the lowercase into uppercase, it's gonna create a new attribute, which we don't want. So if I entered like age in this way, it's gonna have another column for age. Let me fix that. Okay. So this is the last student I'm gonna add, and then create item. So basically now we have created 3 items, and let's start our querying and scanning. So querying is an action that is used in SQL and in NoSQL to return values and items. So if I said query where the age is 21, it's going to give me the student ID, which is student ID is 3, and the name is Michael Brown. So this is what's querying. So if I said query, whereas the major is computer science, it's gonna give me John Doe and the age is 22 and the student ID is 1. So let's try this out. Let's go to query. Let's enter a student ID. Let's enter 2 and then 1. It's gonna give me, as you can see here, we have 3 items. Now we have 1 because we queried on where the student ID is 2, which is Jane Smith. Okay, so let's go to scan. And if we went to all attributes, no, I want specific attributes and I want it to be age. Oh, sorry, age. And we went, no, wait, not this one. So all attributes, and then we went to filters, and then we said, I want age. And this age is gonna be a number. And this, it's equal to 22. I don't know which one is 22. So add filter. No, just one. Remove. So run. It's gonna give me the first one, which is John Doe. We can do that like again and again. So let's put major. And I think we have one which is cybersecurity. Yeah, the third one. So major. And it's gonna be string equals to, we said cyber. Let's see how it's written. So cyber, yeah, security. Run. And 1 is entered, which is Michael Brown. So basically, this is how easy it is to add and do a lot of stuff. So if we click reset and we scan the whole table, it's going to return the whole table. If we want to edit any kind of item, we can click on it, action, edit item, and we can like put her as 21, maybe. And let's say her major is cloud computing. Save and close. So now it's edited, so it's cloud computing and her age is 21. So now if we queried on the age, or no, scanned, where is the age number, and age is 21, I think we're gonna have 2 values, not one, yeah, 2 values. So this is very easy. DynamoDB is very easy to handle and to use. And that's it for today. Let me clean up everything. So if we went to tables, clicked on the table and then delete and enter confirm. Yeah, confirm with the small c. Okay. So now we have successfully deleted the table. It's very easy to create. Let me close and stop the sorry, sorry guys. I didn't mean to leave like this. I have to stop the recording now.